Alright guys, so right now we're going to talk about limits. And what limits are, it's a function, well in the past we talked about functions at particular points, so if you had f of x equals 2x plus 1, we'd sub in 1, and we get 3. Just 2 times 1 is 2 plus 1. Now for limits, we will be interested in finding what happens to a function as x gets infinitely close to some point. And the best way to learn this is to look at examples. So for this one, we talk about approaching from the left and the right. From the left literally means coming from the left side of the point, and from the right literally means from the right side of the point. So this is right here, from the right, and that's from the left. As x approaches x from the left, it approaches the value of 2. As x approaches 1 from the right, it approaches the value of 2 as well. So the point is at 1, 2. So this is from the right, it's from the left right there. Right here, as x approaches 1 from the left, it approaches 2. And as x approaches 1 from the right, it also is 2. But the point at f of 1 is 0. It's not going to be actually 2 because there's a hole right there. Now what I'm going to do is kind of draw out a couple more examples for you guys. So if I have something like this, so this is f of x3, let's call f of x3. Kind of a funky looking graph, got holes, got all that. So as x approaches 1 from the left, it approaches the value of 2. Yeah, so this is coming from the left, literally. This would be from the right, this would be from the left. So if you were to look at the page, literally whatever is to the left is this way, and this is literally coming from the right, or from the positive side. So as x approaches this from the left, it has the value of 2. So left-hand side, value of 2. And then as the right-hand side, it's minus 2. But essentially, the value at f of 3 of x at 1 is actually 2, because the point actually exists at 2. It's a hole there from the right-hand side. We're going to look at one more example right here, which is essentially approaching an asymptote. Let's call this f of x4. Right here. So what's going to happen is as x approaches, let's say this is value 1 again, from either the right, which is this side, or the left, it actually approaches negative infinity. So we get to a definition of what a limit is. I'm just going to erase this to get some space. So what I get is that if f of x approaches a finite value of L as x approaches A, or as x approaches, or as x gets, sorry, or as x gets infinitely close close to A, we say the limit of f of x as x approaches A is L. So we go limit as x approaches A of f of x equals L. So that's the definition that we're going to be using for the limit moving forward. As x approaches A, it's going to be L. Like my L right there, super extended L part. So we'll come back and kind of keep talking about limits